All right, so we're going to look at quadratics in vertex form. Last couple of days has been all about standard form. So there's different things, different ways to approach the problems when something's in vertex form. Okay? So vertex form looks like this. Okay? So it's been factored in a way so that we can see what the vertex is without doing any work. Okay? So actually I like vertex form better than standard form. So the vertex is the point HK. So it's really opposite, same. So opposite of H comma K. Now A is just like the A in standard form. It tells us like how skinny wide or the shape of it and also whether it opens up or down. So if A is positive, it opens up. If A is negative, it opens down, of course. And then A itself, okay, if it's a number bigger than 1, the bigger it is, the skinnier it is. But the thing is, we use absolute value of A because it doesn't matter if it's positive or negative. Like -5 and 5 have the same shape. It's just one's opening up while the other one's opening down. Okay, so they will have the same shape. So only thing is the negative reflects it over the x-axis. So that's why it would open down. Now, if A is less than 1, like 1/2, 1/3, 1/10, okay, that's going to make it wide. Okay, and again, a positive or negative one will have the same shape. And then if A is equal to 1, then I just say that the graph has a normal width, that's a normal shape. Because you have to compare to something, because who's to say what's wide or what's skinny? Okay, so this one shouldn't be on your notes, okay? But if it is, then write it down, but I don't think it is. So let's say we're graphing this. So we'll think about, okay, what's the vertex? Let's see, opposite, same. So 2, 1. AOS. So we use the AOS to help us graph points because they're reflected points. So the AOS would be, it goes right through the vertex. So it's going to go right through, since it's a vertical line, it's going to go through the x. So it's x equals 2. And when you write the AOS, you have to write x equals. If you don't write x equals, you'll be marked wrong because x equals is the equation of a vertical line. Does it open up or down? Well, there's a hidden 1 right there. That's positive, so it opens up. Is it skinny, wide, or normal? Well, 1 was the normal one, so it's going to be the normal width. So I'm going to go ahead and graph 2, 1. Boom. Now we need another point. Okay, so we can choose, since our AOS goes right here, goes right through this vertex, we can choose any number close to this number 2, because we can just choose an input. So like 1 or maybe 3. But you know what? I'm just going to choose 0 because it's close enough and it's a y-intercept, which is a good point to find. So if I want to find the y-intercept, actually I want to find f of 0, just like we do always. When you want to find the y-intercept, you make the x 0. Okay? So -2 squared is 4, and then 4 plus 1 is actually 5. So I have a point at 0, 5. So there's 0, 5. And that is 2 units away from the AOS. So, and it's on the left side. So I'm going to go 2 units away on the right side. And then I'm going to draw my parabola because all we really need are 3 points. Okay, so the parabola does open up and it is a normal shape. This parabola is not the best one I've ever drawn in PowerPoint, but it's a little crooked, but you know, it is what it is. All right, so let's practice finding the vertex, AOS, and the shape. So the vertex, opposite, same. And the AOS, remember, it's always just the x value of the vertex. But you have to write x equals in front. So x equals -4. Now, is this skinny, wide, or normal? Well, look at this number. It's bigger than 1, so it's going to be skinny. It compresses it. It pushes the parabola together. Vertex, opposite, same. AOS, just the x value of the vertex. Okay, now this number here gives us the shape, and since it's smaller than 1, it's going to be wide. All right. excuse me, the vertex here, opposite, same. And the AOS is just the x value, so it's x equals -7. And remember, 1 and -1 are the same, they have the same shape. So this one is a hidden -1, which is the same as 1, so it's normal. Okay, this one here is a little tricky. But if there's no number at the end, it's implied that there's a +0. So opposite same would be 3, 0. AOS is just this, so x equals 3. Skinny, wide, or normal? Well, you would think that this is going to be wide because you see a fraction. But the thing is, if you look at the fraction itself is bigger than 1 because 6/5 divided is 1 1/5. And 1 1/5 actually becomes 1.2. Okay, so that's bigger than 1, so that's going to be skinny. And then this one here's another tricky one, but this is one that I call a hybrid because it could be in standard form or vertex form depending upon how you want to think about it. Okay, so really, technically there's a hidden +0 in here, like x + 0. So if you look at it in vertex form, it's 0, -6. I mean, what we've learned before, remember this is the parent function, just x squared, and the -6 is outside, so it just goes down 6. So it's still centered on the y-axis. AOS is the y-axis, x equals 0, and there's a hidden 1, so it's normal. All right, so hopefully you guys were okay with that. All right, so here's example 2. So let's first find the vertex, right? So remember in vertex form, it's opposite of h, k, so -3, -2. AOS, which is axis of symmetry, x equals the x value of the vertex, because it always goes through the vertex. Open up or down, that's positive, so it opens up. And then that number is smaller than 1, so it's going to be wide. So let's graph it. So -3, -2. AOS is at -3. So I should choose a point that's close to this -3, so like -2 or -1. But I already know it's wide, so I know I'm going to have room to choose 0. So I'm going to go ahead and just find the y-intercept so we get used to doing that. So if I'm finding the y-intercept, remember I set x to 0. So 0 + 3 is 3. 3 squared is 9. 1/3 times 9. Remember this just means divide right here. So 9 divided by 3 is 3. 3 times 1 is 3. And then 3 minus 2 equals 1. So I have a y-intercept at 0, 1. And then since it's 1, 2, 3 units away from the AOS on the right, there's 1, 1, 2, 3 units away from it on the left. And my parabola opens up, and it is wide like this, like we said it was, so I know it's right. I labeled my function right there, f of x. Okay, so let's look at another one. Okay, so we look at this function f. What do you notice about it? We talked about this type earlier. Okay, I called it a hybrid because it depends on what you're looking at or the way you want to look at it. So this here shifts it up 5. This here makes it skinnier, and then that one there reflects it down. So it's still going to be centered on the y-axis. So if you think about it, there's a 0 on the x value of the vertex, and then 5 is the y value of the vertex. Okay, and then the AOS is just the y-axis, or x equals 0. That's the equation of the line for the y-axis. And it's negative, so I know it's going to open down. and that number is bigger than 1, I'm talking about the absolute value of that number. Who cares about the negative? So I know it's going to be skinny. And I want to find another point. So let's find a point that's close to this AOS of 0. So maybe I want to choose 1 or 2 or -1 or -2. So I'm going to do 1. 1 sounds like, much easier than the other one. So 1, f of 1 would be this. So 1 squared is 1. 1 times -2 is -2. Plus 5 is 3. So I know I have a point at 1, 3. So 1, 1, 2, 3, right there. And then maybe I'll just, since it's skinny, I'm going to try another one. I'm going to do maybe 2. I'm going to plug in 2, see what I get. So I got -2 times 2 squared plus 5. So that's 4. 4 times -2 is -8. Plus 5 gives me -3. So there should be a point at 2, -1, 2, 3. Okay, so I got this reflection point. And then 2, -1, 2, 3 right there. And that's 2 away, so there should be 1, 2 away right there. And then I can graph it. I have a lot of points there, so that parabola actually looks a lot better than the other ones because of all the points I have. And it is opening down, and it is skinny, exactly what we thought. Okay. So just a couple reminders here. So let's say it's a multiple choice question on the test, okay? And I ask you to find which function could represent this graph, okay? So first thing I would look for is, okay, it opens down. I want any positive leading numbers to be eliminated, but these are all negative, so this one's a little more tricky than one would be on the test. But what we could do is we could just look at these vertices. Okay, so let's look at each vertex. So that would be -2, -3. This would be 2, -3. This is -2, +3, and that's +2, +3. And I want my vertex to be -2, +3. So that's going to be C. Okay, nice and easy. Easy one. Okay, now what about this one? This one's a little bit harder because now these are in standard form. We still got to be able to do it. Okay, so there's a little trick I can show you. So this only works when your A is positive, but this B value tells you the direction of your shift, this B value. And just like in vertex form, it shifts it opposite direction. So like this is going to shift to the left. This will translate to the left. This will translate to the right, and this will translate to the left. So I know this one goes to the left. Well, if I had my parent function, right? My parent function, y = x², that just goes right through the center, and that was horrible. Okay, let's see. What is that? All right, so it kind of is a parabola that goes through the center, and it's not very good either. But this is the parent function. I want to shift to the right. I want to translate to the right. But this one's going to the left. Same with this one. This one's going to the left. So I can cancel these two out. So now I'm just left with B or C. Well, why don't I just find the x value of the vertex? That's all I need to do is find the x value of the vertex, and I know which one is right. So if I was trying to find the x value of the vertex on this one, right, it's -b/2a. So that equals opposite of -4, which is 4, over 2 times 1, which is 2, so that gives me 2. Let's see, this is 2, -1, so I wanted 2. That's what I wanted. I wanted it to be 2. This one I'm going to have 6/2, which is going to be 3. So that would be over here somewhere. So I know C is wrong. And all I did was just real nice and quick and easy, just found the x value of the vertex.
I don't need to find the whole value. I don't need to find the y value. There's no need to, because they have two different x values. Okay, so that's the reason why in this case the graph, or the correct function for that graph would be b. All right, hopefully that helps.